Hey guys, it's Vince. Today in this video, we're going to be discussing how to work with cables. Now, I get questions all the time on working with number one spindle cables and then general assembly of other CNC cables that require double shielding. This video is going to cover a incorrect way and a correct way to assemble your cables, and I'm going to be covering using a template to properly measure to get the correct length of your leads for your cables. Many content creators do videos that fly by the seat of their pants. Let's jump right in.
So I'm going to try and show you how to prepare and connect one of the sockets. Now this probably won't go very well because I don't have a very good filming setup at the moment, but well, here goes. So you want to remove about 30mm of the outer sheath.
All right, guys, so we see the content creator here getting his cables prepped in order to once again start the soldering process. The thing to keep in mind, and I cannot emphasize this enough, is you can certainly do the measurement process that he's doing. I find measurements like that typically to be off, especially if you've never worked with double shielded cable before. And the thing to keep in mind is that naturally double shielded cable is very expensive. If you screw up and actually remove too much casing, too little casing is easy to rectify, but too much casing means you may have to purchase another cable. I recommend using a template. I prefer toothpicks because usually the amount of cable casing you're removing is very, very minimal, and it should always be minimal in best practice. I will show you the method I use in conjunction with the before of this content creator to go back and forth so you can see one technique versus the other and why I've selected it.
Right, guys, what I have here on the bench is the example of the tools that you'll be working with. In my case, I'm using a large HY spindle connector for this example. Once again, connector type is irrelevant. Any connector this will work with. I do have a piece of 16 gauge DS Flex double shielded right here. It's about 1 foot long. Sharpie marker. We've got here a toothpick and a straight edge razor blade. Once again, real basic. We're just discussing the section of the video that once again you've already seen the content creator talk about measuring and all this other BS. We don't need to do that. Here's what we need to do. We're going to take the connector and we're going to assemble it. So again, these connectors unscrew depending upon how your connector's housing is actually assembled. You're going to want to assemble it in a mock-up format minus the stress relief. Now, why am I saying minus the stress relief? Because it's not required for you to utilize the tool to make the template. In this case, it's going to be a toothpick. So you can see right inside there all of our conductors, the 4 of them. See that? So I'm just going to arbitrarily select one. And I'm inserting the toothpick inside of one. And when I do that, what have you noticed? You notice now where the stress relief begins, and that's why we leave the stress relief off. If we know where the stress relief begins, all we have to do is mark where we want to make the template as far as the length of the toothpick where the stress relief begins. Because if we cut inside of where I leave this mark, what we're going to find is we will be able then to know when that stress relief begins, and you're going to know how long you can remove the casing on your cable. So once again, I'm going to come in here pretty close. It's not going to be exact. It doesn't need to be exact. All I'm doing is making a hash mark, and I already know now, you can see it right there. I know that I need to be well within that line. So if I'm in that line a couple millimeters, I'm going to be set. Okay, so let's look at what we're working with here. I'll just rotate that over. If we come right about here, right where that second line is, we're going to be good. Okay. Now, if you want to get technical, you can measure this, although I don't think that's going to be required. It just gives you an idea of where you can actually remove up to if you're going to do this. Now, the thing to keep in mind, and this is where most guys get lost, is that when they see that length, they're like, oh, hey, I can work with that. The thing to keep in mind is that you have to bottom out your conductors into the conductors on the connector in order to make sure that that length is accurate, because once again, you're inserting the toothpick all the way in to that cup. So if you do not insert a conductor from the cable all the way into that cup, you're going to be longer, and therefore you will come back into your stress relief. So you see how technical this is? I mean, just by me explaining that, some guys may or may not have understood what I just explained. If you haven't, please go back, rewatch the video. But overall, this is a must to understand. So what I'm going to do now is I'm just going to cut this right there. We let that go right there. Here's our length of what we're working with, once again, to give you an idea. Now, before I cut this or transpire this template onto the cable's casing, I want to examine my cable. And why I want to examine it is, you can see here, this is a nice flat edge, meaning this is a clean cut edge. If it's not clean cut and it's on an angle like this, you would not want to use this end. You'd want to trim it level. Why am I saying that? Every detail counts, right? So we want to make sure that we start with conductors that are virtually identical. Now, of course, if you bend the cable, the conductors will move within the cable. That's the whole idea of having that yarn separation inside the cable, is to make sure that those leads are not binding on each other. So that's normal to have those cables move slightly. And I'm talking about those leads within the cable. But what you really want to pay attention to is that you're flat. Everything here is nice and clean. So once we've got that and everything is set, let's keep our area nice and clean. Let's give us the measuring area that we are going to work with. So we're going to stay right about here. And again, that's pretty tight. And I'll just take this, lay this on my cable, very simple, and make an incision right there. And I'm doing it once again with the razor.
Here's the content creator's method, and again, this is not best practice.
At the end of the day, you've got to actually wire this thing up. And if you're like me and nowhere near being a pro, giving yourself an extra couple of mil of cable to play with really helps. So it's better to have a couple of mil unshielded than to screw up the connection because you haven't got enough wire.
Of course, and I'm saying the flat edge. Now watch, I just separate that. You can see where that cut is. So now what I'm going to do is I'm just using a little pressure with my index finger, carefully, and I'm just laying it within that groove. Now I come over to the desk and I straighten it. That's why I like the straight edge razor blade, because I can control how much pressure I'm working with. When you see guys using a utility knife and they're grinding onto the cable, the thing you need to keep in mind is you do not want to cut any of that shield unnecessarily. You want to deliberately cut it when required. Most of these guys don't understand. The more pressure you put using a utility knife or some other cutting tool, you're going to have too much pressure, and therefore you have more of a possibility to create an incision or cut some of that shield. Now you can see how I'm doing this, and you can see the cable is not fully cut. See that? We got a little bit of material right there, and that's okay. But I'm opening up the wound, so to speak, and we're just coming around, and we're doing it nice and slow and nice and steady so we could stay nice and symmetrical. And in this way, when you get it, you can see what you can do. You can work it around. See that? I'm just working it around. And then when I actually see that line, I'll come over and incise it lightly. Now we come in with a probe, and we're just going to come in and pop. And that'll allow the cable casing to break. Once that cable casing breaks, you'll start, and again, you do not want to use a lot of pressure. It's going towards your fingers, so you don't want to slip, God forbid. You want to just take your time, do it to where you can start peeling. More like a banana peel. Pop. Done. Now, most guys will look at this and say, man, that's a lot of cable you've exposed. Your cables don't look like they're that long in the sense of when I actually terminate spindle cables. And the main reason they don't is because when you insert the leads, once again, that's all going to go away. So you can see now where we're at and where this will be when they're terminated. So again, looking at this and understanding, here is your shield, and this is your first tin Brady copper shield. I'm moving everything out of the way. And you can see here what we got. These are very, very fragile, but nothing here is incised. You can see the conductors, nothing has been cut internally of the cable. Here's our shield drain, and then we also have our mylar foil, and this is why these cables are so unique. Once you've worked with this, we don't want to disturb the shield drain if we can help it, so what I'll do is I'll braid it. Just come over here and twine it together. Make sure that's one piece. Keep it clean and nice. Now we've got everything separated. Now you guys can see exactly how you would get your measurement for your leads.
Now we're going to take a look at the content creator's version, and once again, this is not best practice.
Or the outer sheath will break. You can throw that bit away. Take back the shielding. And don't forget, you can always cut these a bit shorter if you think you've been far too generous.
The first area of concern you guys need to pay attention to is how fast the content creator is moving when he's working with the cable. There's only two reasons to ever move that quickly. And when you're making content, you'd want to move slow so your audience will understand what you're doing, number one. Number two, if you're moving that fast, it usually shows on camera that you don't know what you're doing, because again, a lot of what he's doing is just guessing. A lot of it's just, well, approximations. When you make those approximations and you've never done this before, you're going to end up in trouble. It's going to cost you money. It's going to cost you time, because the mistakes you make, once again, when you start dealing with cable, when you start removing things, it will, once again, rear its ugly face in that you have to correct the issue because you can't put back what you remove. Fact. Slow down. Develop your process. You'll develop your own. It will take time. The more cables you do, naturally, the better you get. We can see here, I'm zooming in so you guys can see what he's doing with the cable as far as separating its casing. And I find this really comical because a lot of content creators actually do this. They'll put a warning on the screen. Try not to cut through the outer sheath. Use the bending of the wire to complete the cut. This stops the inner sheath getting damaged. Meanwhile, he's telling you this and using a utility knife to cut through the cable's casing. There's no way he's doing that gently, and certainly not gentle enough to where you're protecting that shield underneath. Now, this cable he's using is not double shielded, but it still has a shield. You got to pay attention to what you're doing. You have to think with a level of detail that's required for what you're trying to accomplish. When we see this, this will once again develop a lot of bad habits and get you into trouble quickly. This is why listening to these content creators, and I've said this before, you have to be careful. You do not know who these people are. You do not know what level of detail they perform, and you do not know if they have the knowledge other than watching what they're doing, if it's actually there present for this application. Pay close attention once again to how fast he's moving, and also take note on he's using the incorrect tool in that he should be using flush cutters to work on the shield and any internal structures of the cable to have them removed, whether it be mylar foil or whether it be a shield drain to shorten it to length.
Take off the inner protection. This stuff was specially designed to gather static. Once you've got it on you, you won't ever get it off. It sticks like it's glued. Now inside you'll find that core, that piece of cotton, get rid of that, and you've got an inner rubber core which you don't need. Just nip that out. And there you go, you've got your 5 cores. Grab your wire strippers and strip off a bit.
Many content creators will use a stripper, as we see here in the video, to once again strip the internal leads of what cable they're assembling. The thing to keep in mind, guys, is that these strippers are really designed for less accurate type stripping. Meaning when you're doing precision work, you really want to stay with a flush cutter and do it manually, because unless you're using strippers with a very precise way to measure how much of the cable you're stripping, and believe me, I have Knipex and they work excellent and they do measure, but for doing fine work like cable assemblies, I highly recommend using flush cutters, and I'll illustrate exactly the best process coming up.
Okay, now what I'm going to do is I will peel everything off, I'll clean this up, and then I'm going to show you exactly going into the cable itself on how we're going to terminate, and then we can check our leads to make sure that they are done correctly. All right, guys, I wanted to show you, because I know there's going to be some guys that want to see this. You can see I've removed already the tin-braided copper shield. Okay, so now we just have the Mylar foil. The remnants of the tin-braided copper shield are underneath the casing as they should be. Okay, so regardless of what cable you're using, once again, I'm one of the rare few that actually do the cables in the sense that they are clean as a regular cable, meaning the shields are underneath the casing when not being used. If you're going to terminate this now, what we're going to do is we're going to remove, and you can see the yarn separators, and here is the Mylar foil. We incise the Mylar foil carefully, and now we just peel it like a banana. Move the shield drain out of the way. You're going to see. Now we have a little bit right here. We just incise. You see how I'm coming in this way? I'm not coming in like this. This way, we do not give ourselves a chance to make any problems with a conductor as far as its casing. Now what I'm doing is I'm using the Knipex, there we go, just to peel some foil. And then what I'll do, if I have to get in here in this manner, I just fold the leads out of the way, trim it back as much as possible. We're good there. Move our shield drain, try to keep it perfect. We do not want to screw her up. Once again, if we have a bigger piece, we'll come in, make a snip, and peel. And the closer you can get this, the better off you are. If you can use the yarn separators to actually keep your tool away from the casing of the leads, you absolutely should. It's going to give you more of a buffer of safety. So now you can see we've got our yarn separators here. Okay, so now that we've got our yarn separators, the other thing to pay attention to is what leads, and every cable is going to have this. Even if we were cut level, you can see our leads are not perfectly the same length. We're going to get to that point. But you can see right here, we first got to get rid of all of these yarn separators. So I'm going to pause the video, I'll do that, and then this way we can move on from there. All right, now you can see with the yarn separators removed, everything under the casing as it should be, where we're at. We do have a couple leads, and mainly the black and the white, that are slightly longer than our ground and our red. See that? We can see exactly what we're working with here. Now we've got this shield drain, which is still very fragile. We're going to bind all those together. Once again, Kester 186 RMA flux, put a drop on there. See how wet that is? Right now, iron's heating up, 752 degrees Fahrenheit. That's it. Now we have a solid piece of our shield drain. Why do I make a solid piece? Because now it's less fragile. See, we can touch it and it's not going to be all screwed up. Next thing we want to do, you want to get your cable in virtually the straightest possible position so that we can begin to trim these conductors to where they are matched. And you can see I'm using a pair of Knipex, and these are flush cutters. And you can see why they call them flush cutters. Once again, index finger carefully placed, not with too much pressure, over the top, so our ends do not shoot across the room like you just see me do with the toothpick earlier. And now these are looking really pretty. So now what we're going to do is, you can see what we've got here. I'm just bending this out of the way. And you can see that if we come up here, you can see where they're going to bottom out inside of the cup. Now that's not all the way inserted, but very, very close. Let me just move my hand back Just trying to autofocus. There we go. So it just gives you an idea, okay? Now, depending upon what length you want to work with, naturally, the shorter these are, meaning I can cut these back, and I myself am more than confident that I can work with a much smaller lead. I could probably come back, for me, maybe 1/4 of an inch, maybe a little more than 1/4 of an inch. For guys that are not confident with their ability to work with much smaller leads, at this point, you'd want to carefully look at when you're going to remove the casing on these to insert inside those cups. Once again, if you come too far back, it's going to basically give you a bald spot on your conductor. We don't want to have a bald spot if possible. So what we want to do, once again, we want to take the template and see where that conductor is going to be. And all you have to do that is just stick it in there the same exact way. And now you're going to make another mark. Now you know where that conductor casing should relatively be. And it's sure in hell going to be better than guessing. We're taking a ruler and estimating, because that's what I see a lot of these guys do, is they take a ruler and they assume that they can do that and get an accurate measurement. So now what we've got is the idea that it gives you an idea of just how far back, just by looking at that mark, from right there on the end of the lead, and I'm talking about the ground lead, all the way to where that mark is, of just how deep that goes within the cup. So you realistically could cut some of this lead back if you're not going to insert that all the way into the bottom of the cup. Now, I've had a lot of guys ask me, does that matter? Meaning, if the lead, if it's not cut all the way back, meaning the lead itself's casing is not removed and the conductors that are bare are not inserted all the way to the bottom area of the cup. It realistically does not matter. And I'm going to tell you why it does not matter. Because when you use solder properly, solder is a conductive substrate, okay? It's going to take all of this material, whatever you have left there, and fill that up into one solid mass. So when it becomes one solid mass, regardless of how much conductor is left within the cup, if there's a gap, if you use flux properly, it's going to work with a wetting process to fill that gap. Think about what I just said. Yet for some reason, we see guys constantly fighting because they're just using solder without the flux. And that's what most people end up doing, is they sit there and they fight and they fight and they fight and they fight the iron, they fight their tools. If you use flux properly and with every connection, you should never have to fight your connections. So now that we know where we're at here and how much room we actually have on our conductor, I'm doing this as if I've never done it before. So I already know I'm going to come back, and if I do not actually remove that amount of casing, or I do not cut this lead right there, I'm basically SOL, because what's going to happen is it will once again, with the exterior amount of casing left, if I don't come all the way back, if I leave casing, let's say up here, it's going to push this cable farther back within our housing, and therefore it will push the piece of the cable which has already been removed as far as the casing right into the area of the connector's housing where our stress relief is. So that is a no-no. That is not what you want to have happen. So once again, being detail-oriented, you want to take this and you do your measurement process, and you can see you can make a mark right there if you want to know how much you can remove. Now, that's the thing to keep in mind. Where do I want to remove from? Well, right now I'm dealing with a pretty long lead. And I did that intentionally because, like I said, I can either choose to remove more of the lead over here and get it closer to back here, or I can remove more of the casing and come back to here and just insert more of the conductor bare into the cup. You see what I'm saying? I'm giving myself a way out so that I'm not pinning myself in and saying, okay, it's exact. There is no exact with this. It's very close. Remember that. Nothing is perfect. It's going to be very close, and that's what we're aiming for. The thing to keep in mind is you don't get a second guess with this. Once you start cutting or removing casing or making any incisions, you're SOL. That's it. You move too much, you can't put it back. So you want to move slow. So once again, what I'm going to do is I'm going to have her just pause the video, and I'll remove some, and I'll show you exactly what I did in order to do this. All right, so I trimmed back the casing. Here is our conductor, twined it together, then leveled the conductor, meaning I used flush cutters right here and trimmed it. Once that's done and you got a nice conductor and you can see everything is symmetrical, now the key is this. We're going to apply a drop of flux, okay? And instead of going to tin in the traditional fashion where we come back, we're going to just do the tip. Why do we do the tip, you say? We do the tip to maintain perfect flexibility. Watch this. Did you see what just happened? The solder creeped. Why did it creep? That, my friends, is exactly what wetting action is, and that's exactly what you saw happen. It just went, and through capillary action, just backed right down. The beauty is you can see all of that bare copper right there. That means nothing went back under the casing. We still have pure flexibility, which is a beautiful thing. So now what we're going to do, come over here to test my theory of where I've made this lead. I'm just going to measure it. You can see exactly what we got. That's totally level right there. You also notice the casing is perfect. There's no degradation. We don't have melting, and we don't want that. We want it nice and clean. Everything is set. So once you do your measurement, and let's say you're slightly off, the beauty of this is, watch this. Turn your heat gun on. Precision heat gun is really best. Small tip. Come over here and heat your casing. If you need to make a fine adjustment, heat the casing, get a nice set of needle nose. Very gentle. And just push back. And that'll give you a fine adjustment. Why? Because once that casing has been heated, it's softer. If it's softer, we can manipulate it as long as we're gentle and we're careful. We can come back and give us a little more room, a little less room, whatever we need to work with. This will come out perfect and right there. And you can see we got a tiny little gap now. See that? Right on. So this right here is the easiest way to work with. Now, I told you about the shield drain. And once again, when you're working with double shielded cable, you're going to have the shield drain. On a spindle type cable, we would remove the shield drain on this end. So therefore, what I did here, I did just for illustration so you guys could see what I'm doing. But now what I'm going to do is remove the shield drain. So once again, we got a nice tight twine going on. We do have that solder on top, holding everything nice. Then what I recommend doing is folding the cable. Why do I fold the cable? You say, what the hell are you doing, Vin? I'm folding the cable because then what ends up happening is any movement in the shield drain will come forward. If it comes forward, it will hide itself when I trim it flush with the casing. You know how I know that? Years of experience. That's how I know it. There's no college course for this. There's no somebody, just telling me, hey, try that. You have to be willing to try all of this in order to get to that level. And that's what I'm telling you guys. So we come over here, we'll fold everything out of the way, make sure we're clear on our casing. You do not want to hit any of those conductors. Trim. Now watch, when I straighten the cable, it's gone. That's all tightened back there, perfect. Everything looks good. We'll clean our conductors now because of course you get rubs, and rubs are normal. So what we do, we have a Q-tip. Perfect. Here we go. And I clean the cable. This way everything is nice and neat. Nice and neat. This is all good. Now that we're all set here, and you've got that lead already measured, if this lead is measured, in order to cut these leads, all you have to do is move them carefully out of the way, line this one up because it's already been leveled with all of the remaining conductors. Once it's been lined up, take a pair of flush cutters. Now these I sell, and these are 90 degree. Why are they 90 degree? Because they get out of your way. Watch. Come right here, pick where we want to go. Now you notice I'm cutting above where that conductor is, slightly above. Why? Because then I can manipulate it again when I use my needle nose. So I come in, I make a little slight score very lightly, and I rotate carefully. Do it again. Patience is a virtue. Done. Here's your casing. And if we look, you can see that casing is slightly higher than our ground. Now we come over and twine. Once that's done, watch, this is where it gets fun. Okay, once again, I'm highlighting this. You can see that casing is slightly higher than our green casing. Now what we're going to do is the same exact thing. We want to make sure that this conductor is going to be tinned, because once it's tinned, once again, it's much easier to handle. You're not going to have these leads fray on you. So once again, wake up our soldering iron, clean our tip. Now a lot of guys are jabbing. We don't want to jab. We come in carefully and rotate. There's no reason to be jabbing, whether you're using a sponge or anything else. Everything is gentle motion. We're not trying to destroy our tools. We're just trying to get the process that we need done. So once again, apply flux. I want it wet. Come over to the tip. Once again, right to the tip. There's that capillary action, a beautiful thing, and there you go. Now what we're going to do, because I told you we're a little high on that casing. Done. Needle nose. Now you're perfect. And you can do that over and over again as long as you're gentle, and you're set. Right on. Those look great. This one you can see has a more of a rough edge on the tip. You can trim these whichever way you want. Once again, flush cutters are your friend. Don't be afraid to use them. There you go. And you can also see then how those conductors are bound together. If you see any gaps and you do not have full solder penetration, you will see gaps. This is exactly what you want. And once again, we've already done 2 leads to give you an example. So you can see here just how easy this is. Once they're inserted, you're in. That's it. Boom, boom. Perfect. So this is why I'm telling you guys, you just have to be very careful on what you're watching. When guys are not doing this all the time, their process is more of a hit and miss process. You don't want a hit and miss process if you're doing this with this expensive cable. Okay, many of the content creators I do videos on never use the proper cable. So if they're wasting cable, granted it's still money, but it isn't this much money. So the whole idea here is to formulate a process, do it correctly, and do it in a way that, once again, you understand how to take measurements and how to work with it to where you're going to get the end result you want. Now, what's really interesting is when these leads are all cut, they basically just fall in. You're not really having to do too much other than that if you follow the process I've just showed you. Again, the more detail you do, the better you'll get at it. The idea is to always leave enough room for error in case you make an error. A lot of guys will cut far back, and then you'll see them in the content creator videos where they'll have the casing way back over here, and their stress relief will be all screwed up. You don't want to do that. You want it to be right. You want it to be professional. This is how you be professional. And again, paying attention to the details. Remember, flux is going to make your solder creep. And again, the wetting action, the capillary action is going to allow that. And that's exactly what you want, but be prepared for it. You know when it can do it. You know when it can't do it. You know when you can fill a cup. It's the same principle. I'm going to do that as we go through this video, but hopefully this has helped you guys see exactly what's possible. We'll move on with the video.
That's really quite generous. That's about 10 mil. You don't need that much. 5 would do it, but as I've done the first one, that much. Now, what is important is all your cables are the same length. It doesn't matter if you removed a little bit too much sheath on that one, there's ample space in the connector.
What I really enjoy is watching someone who really doesn't understand the level of detail building a cable requires. And then he goes into detail about telling you all you need to worry about really is that the leads are the same length. Guys, this is a very, very detail-oriented process to assemble a cable correctly. Any cable. Watching someone like this, where they're arbitrarily just stripping casing, they think that you can just get by with winging things, and in the end, it always ends up the same way. When you lack attention to detail on jobs that require precision and detail, you will screw yourself. This guy should have sat there without the camera on, built a cable repetitively, gotten well at it enough to where he could project what he's doing in best practice to his audience. Once again, that's the difference between being a responsible content creator and someone just looking for clicks to get paid by AdSense. And of course, unfortunately right now, YouTube can't decipher with the algorithm the way it's set up of what's real and what isn't. But if you look at what I've done and you watch that this guy makes it look so easy, we just strip the cable leads, everything is good. All you need is the leads to be the same length. Really. So if you don't use a template to actually find out how long those conductors have to be inserted inside the cup, meaning the connector's cup you're going to attach it to, how will you know you're stripping either too much or too little for that conductor? Logical question. Not shown here. Think about what you're seeing.
Same length is just make sure when you cut the cable, you just cut it square across. So just lightly twist the ends.
Here's where we see the content creators work so far. You guys can see for yourself the orange lead in comparison to the black, white, blue, and green ground lead has its casing removed a little bit more, meaning that the casing starts lower than the remaining leads. I'll put an arrow there so you guys can identify it. What does that mean? Well, it gives this content creator two options in order to correct what he's already done in best practice. He would actually have to either shorten the other leads to bring them in symmetry with the orange one so that they could all be stripped in accordance to having an even dimension going into this so that the connector, once it's installed, that meets all of the casing as it should symmetrically, or he would shorten the leads down to whatever length he determines once again and starts over. These are all adjustments to length pending, and this is a critical detail, that you have a cable that's long enough, or I should say in excess long enough, to support your project making these adjustments. And this is interesting because this shows just how novice this guy is. You don't know that potentially as a novice until you get to that level. That's why you guys use my videos, because guess what? I've already been burned that way myself, and you're learning from the past history of me performing this repetitive motion time and time again to get you guys out of harm's way, and that's what I get paid for, because that level of experience only happens when the camera isn't on. It happens when you've attained that level of experience, and hopefully content creators will execute some sort of responsibility to where once they have attained that experience, those are the content creators that deserve to be paid. Think about what I just said. I think that makes total logistical sense, and when we see this, that's just the baseline of the problem. Let's look at the other issue. We have it looks like a plastic wrap insulator, and then we also have the shield that's actually protruding above where the cable's casing is. That is not best practice. You shouldn't have any ground conductive material ever exposed by the casing of the cable. Why? Because God forbid any of that conductive metal material makes contact with any lead or terminal, and you guys are SOL. And again, and I've said this in previous videos, if there is a catastrophic failure, God forbid, in your shop or your home and you have insurance to cover these assets, you will not be paid if a fire marshal has a forensic inspection done on a cable that is built incorrectly. Fact. These are facts. You can call your insurance company and find out. Bottom line is this. Most of you already know in whatever country you are, whether it's the US or anywhere else, European Union, that insurance companies have the best lawyers in the world. And the worst thing that they can do is have to pay. They don't want to pay. So that means they're going to put all of their resources on whatever you go to make a claim on, and guess what? They're going to make sure every T is crossed and every I is dotted, because it's going to be a fact that they will go through every bit of detail it takes to not have to pay you thousands and thousands of dollars. So it's up to you. Looking at this, when some guy just says, hey, this is how easy it is, just do this. I don't think it is. And now you guys are seeing where you're at. I'm going to put my cable up on the screen here so you can look in comparison of what a cable should look like in best practice, where again, everything is cleaned. Whatever is left on the cable that's not to be used is removed cleanly. And that means that the casing is the only area of exposure. Everything else is removed. And you will see here, that's exactly what you have with my cable. What we see with this is just a complete mess.
So once your soldering iron's up to temperature, take your solder and just tin up your wires.
All right, so we got some more direct areas of concern here. Number one, when you're using an alligator clip with metal jaws that are not being protected on your cable in any format, whether it makes contact with the leads, whether it makes contact with the outer portion of the cable's casing, you are going to make marks on it if you don't put a piece of heat shrink over the alligator clip jaws or a piece of silicone tubing or something as a buffer so that you're not crimping right on these precious casings. The other thing that we see being done here, as it's been done billions of other times over with many other content creators, is he fails to understand the importance of flux and how it plays a critical role in soldering process. Guys, I'm telling you right now, once you've soldered with the proper flux and see just how fast and easy it makes your life, you will never go back. Number one. Number two, it's best practice. So just do it correctly and save yourself the headache, and know that not only is your system built correctly, but you've got the proper tools to do the job right.
Okay.
Well, we can see here the content creator likes to practice cooking, because that's essentially what he's doing with the conductor he's trying to solder. Guys, real simple. Practice this rule. When using the proper flux combination with solder, the 3-second rule. If after applying heat from your iron set at the proper temperature, using the proper flux in conjunction with the proper solder, you do not wait in excess of 3 seconds for proper bond to be set. Think about what I just said. If the connection is clean, using the proper flux, you're using the proper solder, and you apply the heat to those two components, you will find that within 3 seconds, you will have a joint formed. That's simple. What we're seeing here, and we've seen this many times, where content creators just cook and cook and cook and they're not doing anything. This is where a point of logic should have dawned upon the content creator. Hey, maybe I'm doing something wrong. And he'd figure out, if he did a little research, that he needs flux. The other area of concern that I'm going to solve real quick, because this is one of the biggest questions I get, is how do I make sure that those leads are bottomed out in the cup to give me a nice symmetrical lead entry point into the connector. And you guys are going to see that being done. I've already covered soldering done on my videos many times. That will not be covered in this video, but you will see how to do a mock-up on a cable insertion in the connector so you know exactly how to jig everything and have it all meet perfectly in a mock-up form, so all you have to do is apply the proper soldering flux.
All right, so to wrap it up, let's see with all the other leads done how this fits. First, we're going to insert what we've just done with the cable. Now, my recommendation, and I did this on all mine, go over and just make sure you don't have any rough edges. And this is a deburring tool, Shaviv. I'm just coming in here to make sure we're nice. Everything is nice and deburred. Anybody that orders a cable from me, that's the first thing I do. Again, details everything. Insert it. Well, all we're doing is testing, right? So the mock-up has to be exact to make sure that the measurement is correct. So what we're going to do is we're going to accurately put the leads in just as they would be put into the connector when they're going to be soldered. And you can magically see everything just fits right into place. I'm just getting that red guy in there. There we go. Everybody looking good. Whoop. And we're in. See if I can get a firm grip. Right on. There's your mock-up. So you can see everything is perfect. Now what I'm going to do is bring in the bottom casing. I go backwards first. This way I can align my threads. Once again, backwards. We don't want to cross thread. There we go. And now we just bring in that back end in. Everything is inserted. You can see exactly where we're at. So again, guys, this is not magic. This is what can be done when we take proper measurements, and you can see exactly where we're at here. Your stress relief is perfect. Everything there in depth is done and done the correct way. So it can be done. It's a question of understanding the process. You just seen it done before you. This is real. Right there. So now you know the only thing would have to happen naturally is you would insert the conductors into the cups just as they are naturally without the casing in place, and place your solder and flux. And magically, everything is done. There you go.